Morning, everybody. My name is Mike Johnsrud. I'm the Executive Director of PCI Midwest and the moderator for today's webinar. Today's presentation is sponsored by PCI Midwest. PCI Midwest is a trade association representing the precast concrete industry in Iowa, Kansas, Minnesota, Missouri, Nebraska, North Dakota, South Dakota, and Western Wisconsin. PCI Midwest is dedicated to providing quality precast concrete education and assistance to the architectural, engineering, and construction industry. Our members' products include both architectural and structural precast concrete for building projects of all sizes. Before we get started, I'd like to invite you to attend a webinar that PCI Midwest and the other chapters of PCI are sponsoring on June 30th. The presentation will include a case study on Chicago O'Hare Airport's newest parking structure and consolidated car rental facilities. This webinar is free to attend. We've all gotten used to virtual settings, but I know that not every platform is just a bit different. So before I turn things over to our presenter, I thought I'd like to review a few housekeeping items. First, you can submit any questions by typing them into the questions pane. We'll take time to answer questions at the end of the webinar. You can download a PDF of the presentation via the handout section on the GoToWebinar control panel. Don't worry if you can't find it, because links to the handout and a recording of the presentation will also be emailed to you after the webinar. Attendees who have fully participated in today's webinar will be issued a certificate of attendance for 1 professional development hour or 1 AIA learning unit with HSW credits. You must attend the majority of the presentation to receive a certificate of attendance. A link to the certificate will be emailed to you within 10 business days. If you provided your AIA number when you registered and you attend the majority of the presentation, we will report your attendance to AIA for you. If you are currently viewing this in a group setting where only one person has logged in to GoToWebinar, you will need to email Margaret Mills with the names and contact information for everyone there with you. Otherwise, she won't be able to send the certificates of attendance. The course description and learning objectives were listed in the registration process, so I won't take time to read them now. I'm sure we'll cover every one of the learning objectives and then some. Remember, we will answer questions at the end of the presentation. Finally, let me introduce our presenter. Dirk McClure is the Director of Business Development for Enterprise Precast Concrete, Kansas City office. He oversees the 5-state territory of Kansas, Missouri, Illinois, Arkansas, and Northern Oklahoma. He received his Bachelor of Interior Architecture from Kansas State University's College of Architecture, Planning, and Design. Prior to joining the precast concrete industry in 2004, he spent 8 years practicing sports architecture. His diverse AEC industry background gives him a unique overall knowledge of the built environment. Dirk, you should have control of the screen now.
Fantastic. Thank you, Mike. I want to welcome everyone and thank you for choosing to spend this hour with us. I like to start out my talks with something inspirational, and I have something really great planned today. There is an architect in Omaha, Nebraska named Vanessa, and she and the team that she leads at DLR Group, they are just really doing some fantastic things with school design, both in the area of unlocking the aesthetic potential of precast and just really pushing the envelope of what you can do with precast. Vanessa was a speaker recently at the International PCI conference earlier this year in March in Kansas City, Missouri. She spoke at our Precast Perspectives seminar. So with that, I'm pleased to share the perspective of Vanessa on an architect that is designing schools with precast.
I'm Vanessa Schutte, K-12 sector leader with DLR Group. I've dedicated my career to designing schools for communities across the Midwest. In my time, I've designed 3 elementary schools thus far and 6 high schools, utilizing precast as a construction method. I've really enjoyed utilizing precast because of its flexibility and the ability to tie design into the project. For example, one of the elementary schools was DC West, and the community of DC West is along the river, and so when you look at it from an aerial point of view, you can see how the water moves through the school district, and there are several lakes, and thinking about how water moves and waves, and how waves kind of, when they go up on the shore, the sand kind of rolls and rolls back. That really served as the inspiration for the design of DC West exterior. There's a brick pattern that we utilize, a custom form liner, where the brick starts very dense and dissipates as it moves forward or up the panel. Really looking at the idea of how sand moves and with the waves of the water. Other areas of the building focus on a different aspect, utilizing exposed aggregates and reveals. It mimicked the idea of grass along the river's edge and water moving through it. That's just one example of how you can customize a design idea utilizing precast. I also enjoy the fact that it's an easy material to engage students in the design process. We've worked with students to design custom brick or custom form liners so that they can leave a lasting legacy on their future school. They can bring their grandkids back to see it once the building is done. And that's one thing that's great about precast. It is a long lasting project. Our owners know that, our clients know that they're getting a building that's there for the test of time. It's not a simple, cheap little, gonna be gone in 10 to 15 years material. It's there, like buildings used to be built, it's long lasting. I also think once you've designed one precast building, it's very easy to go and design the next one. There are some simple rules of thumb the designers need to follow when you lay out a building and thinking about it from a precast approach. But once you know those simple rules, you can apply them from that point on, and you know your limits early on. Although I do have to say I really enjoy working with enterprise and trying to push the limits of what's possible. So coming up with an idea and saying, I'd love to do this, is it possible? And working with them back and forth has made some design iterations that we dreamt about that we didn't know would be feasible from a cost standpoint, more economical. So they've been a great partner in the design process, and I look forward to the next precast project I get to do.
Well, I have a lot of content to go through in a short amount of time, so I am going to go through these slides pretty quick. I will tell you my midlife crisis outlet's a Harley Davidson, so I'm used to moving pretty fast. I think we'll be okay. And in the words of the late, great Heath Ledger's Joker, here we go. It's been a really chaotic couple of years with the pandemic. And one of the things that we saw was a shift in the goals of how job sites are operated by general contractors. And we saw one of the things that we saw them trying to do was a goal of producing as much of the building envelope off-site as possible in a modular fashion. That's something that precast obviously naturally fits into. It is a modular item. If it's an insulated sandwich panel, it's the entire building envelope. It's produced off-site in a controlled environment. During the height of the pandemic, they were obviously had emphasis on cleaning, sanitizing when it was applicable. They were wearing masks. They were taking temperatures every day, doing everything they could to keep their employees healthy and keeping those projects moving so that those commitments could be made. Another goal that we saw was having fewer people on sites and fewer deliveries to the job site. So these do ship out to job sites on flatbed trucks. They're typically very large panels, so there are fewer deliveries. And as far as an on-site crew, you've got about half a dozen people. You've got a 4-person, you've got a crane operator, you've got a few iron workers, really a minimum crew of people that are working on that job site. Speed of construction became an important aspect. There was a goal to get on and off these job sites as quickly as possible. So with precast, you've got 9 to 14 panels a day going up. So these projects do go up remarkably fast. And the aspect that became very important during the pandemic was the all-weather construction aspects of precast. One thing that we ran into a lot, a major challenge, was the schedules were moving around on all the projects. It seemed like there were projects delayed because of uncertainty, and they would pick up quite abruptly and be in a big hurry. They would delay because of delays from other trades, supply issues. So typically with other materials, you have that time in the dead of winter where from December to February where you just have to stop. But with precast, as long as the footings and foundations are in place, they can install all year round. So that's a huge benefit because you can get your enclosed building by winter, or even you can get an enclosed building during winter. That's enough about the pandemic. Let's talk about aesthetics. What you see here on your screen is the 4 primary precast finishes, and I'll start at the top. Sandblast is the most common finish in the industry. There's light, medium, and heavy sandblast. Each yields a slightly different appearance. It's an abrasive blast technique. It starts to expose some of the rock to varying degrees. It's a more dull appearance. Then you can do what's called an exposed aggregate finish, and that is where a chemical retarder is sprayed in the bottom of the production bed. It keeps that surface fraction of an inch of concrete from curing. So when the panel is extracted out of the bed, because it is poured exterior face down, premium face down, they wash that surface concrete off and it exposes that rough rock. Then you can do what's called an acid etch finish, which is a liquid-based application. It is the least evasive finish. It just knocks off the form finish, gives it a nice consistent appearance. It's many designers' favorite finish. It's my personal favorite finish. And there's things you can do with mica sands and silica sands that can give it a glimmering appearance, almost like a sugar cube. And then there's also polished. We traditionally haven't done a lot of polished finish just because it's a machine process similar to granites, so that extra step makes it a bit more expensive. There have been some strategies employed lately to make it more reasonable, so we're seeing a bit more of polished as well. The interesting thing about a budget-conscious project, if you're working on a school, and the favorite way an architect has ever presented this to me, he said, I have this client, he has champagne taste, but he's only got beer money. How do we make that precast dollar really stretch? Well, what you see here on the left, everything gray is one mixed design. Everything you see to the right that is red is one mixed design. One great strategy is to distinguish with textures instead of multiple mixed designs. And you can put multiple mixed designs in the same panel. If you're dealing with an AB or AA certified producer, they would be glad to do that, and that's a great aesthetic appearance. But if you're looking to just shave a few dollars, you can use one mixed design in each panel, and you can pair these up separated by reveals. So you might put acid etching and exposed aggregate in the same panel, or you might put sandblasting and acid etching in the same panel and begin to pair those up that way. We also encourage the articulation through forms, and whether you're going for a more traditional look or a more contemporary look for your school, this is something we really encourage to get you out of just that typical flat panel, flat plane design. And you're literally only limited by your imagination with what you can do. You can get into quite a bit of detail. And what takes that additional projection and that additional formwork and makes that less cost prohibitive is repetition. You can see on this project, they had some cornice work, some sills, some additional detail around the windows. But if you notice, they did that again and again. So repetition is a pretty big deal in the precast business, and that is a strategy to keep your projects within a reasonable cost range. Another tool in the toolbox that you have are form liners, and these can be done with their standard form liners, and you can also do customs. This IRS Service Center used a custom board form that was built in the production facility, and it employed another strategy we talked about earlier. The raised portions are acid etch finished, the lower portions are exposed aggregate. So you had two finishes in the same panel and the use of a form. For Sporting KC's training facility, that's a soccer club in Kansas City, they have a diamond as part of their logo, and they wanted that branding to be part of their facility. So they did something a bit on the extreme side. That's actually a 7.5-inch projection on that custom form liner, but it yielded a striking result. It's anytime it's hit in different times of the day with the sun, it's always got a different look, and it is a very visually impressive building. And that's an example of something you can do with a custom form liner, but you can still see, even though it's custom, they utilize the repetition. Thin brick is another great tool in that toolbox. Your typical sizes are going to be standard, modular, or utility. There's a wide range of colors and textures that you can choose from, and you're not limited to running bond with a single color. You can do arches, you can do projections, you can do random blends. There's all kinds of great things you can do from an aesthetic standpoint. The way it works is you can see here them on the left, them putting the thin brick into the production bed. There's a form liner that's put down. That form liner has a little curved lip on the edge that emulates a tuck point. And then when the concrete is poured directly on top of that, after the reinforcing is put into place, and it bonds with the back of those grooves on those thin brick. You can see on the right how they handle corner pieces to pass that illusion that you're looking at a full brick, but it's actually about 1/5 of a brick. So it's more cost effective, it's more efficient, and it's a bit more greener because you've got more lean, mean, and efficient design. You can also, in addition to having corner pieces, you can have edge pieces at your head and sill conditions. And again, you can do arches. There's all kinds of strategies of what you can do with an embedded thin brick. This project was, at the time, one of the largest college stadium renovations in history. It utilized a random blend with a tumbled brick, and it yielded a really striking appearance with a thin brick. That won an International PCI Award in 2019. Another tool you have, in addition to thin brick, you can also embed stone or tile into your projects. The example on the left here is actually a higher education school. It was a school of business out at UMKC, and this was originally envisioned as terracotta, and that is what you're seeing there is terracotta. It was going to be set into a rain screen with a air barrier and a traditional wall built behind it that would have been a non-precast solution. They realized they had a major budget issue with doing that, so the precaster was brought in to explore the idea of setting the terracotta into precast, which is done quite often now, but back at this time, around 8 years ago, it had not been done in the United States. So through a lot of research, development, testing, we did proceed on this project, and the terracotta was cast into an insulated sandwich panel. So you had the terracotta, 4 inches of concrete, 3 inches of insulation, another 4 inches of concrete, and it ended up creating a savings of over 30% on the building facade cost. The architects who describe themselves as self-described building envelope nerds, they actually did an analysis study and determined that the precast solution actually performed better than the original, more expensive design would have been. A similar story on the right. This is actually limestone that was set into precast. The project on the right, they couldn't get the schedule or the budget to work. A precaster was brought in to explore the idea of taking small pieces of thin limestone, setting them into larger pieces of precast, delivering them to the job site. So this project came in $3.5 million under budget and on time, and that was a $75 million project. So huge success story, made us feel good as precasters, made me feel pretty good as a taxpayer as well. But what I'd like to point out about both of these projects is what you're seeing on these images, no sacrifices were made in terms of aesthetics. So this is exactly what it would have looked like on the left, terracotta in a rain screen, exactly what it would have looked like on the right if it was a full masonry project. So those were a couple of big success stories. When you're doing a natural stone, unlike brick or terracotta, which is a clay-based product and can be directly adhered to the precast, with a natural stone, you need to maintain some separation between the concrete and the natural stone, and that's done with a clear film called a bond breaker. So holes are pre-drilled into the natural stone, and then stainless steel pin anchors are put in, and that is how several pieces of stone can be cast into one piece. And they're not just put in randomly or willy-nilly. Each piece is individually engineered to the needs of the project. So that is determined by the structural engineer for that specific solution. Another new finish we're seeing that could have some great application to schools or really any project is what's called the distressed finish. And this is something that is achieved with a powder at the bottom of the bed that actually gives the final appearance that grainy look. Some architects have used that and leveraged it with through creative use of reveals. It can actually give the appearance of a natural stone, a travertine stone, but for a fraction of the cost of travertine. So we've seen it used that way on some projects. On other projects, we have a partner in Texas called HKS Architects, and they just liked the look of it. So they wanted to use it more monolithically, so that it was used on a large scale in the Texas Rangers' new ballpark, which is where they played the World Series during the pandemic. And they used a few of those tools in the toolbox we talked about. You can see the thin brick there and these arched panels. You can see the distressed finish. Another strategy that I'd like to point out is through color staining. And on this dorm project for an art school in Kansas City, Missouri, they did precast with two finishes. So the white that you see there is an acid etch finish. To the elevation there on the left, those little brown zones you see, that is actually exposed aggregate. That's the rough rock look. And the unique thing that they did on this project is the windows, they tapered them in, and what you're seeing there, that's all precast on those tapered windows. This was done with an insulated sandwich panel that was exposed on the inside of the dorm rooms, but then it was hit in the field with these little pops of color through a custom stain. They wanted to do something fun, creative, playful. In this case, they were Art Institute students, but I could see that being fun for students at an elementary school or a middle school or whatever you're designing for. We do encourage you utilizing the precast community to get a precaster involved early to help plan and save cost. And there's a few benefits of doing that. One is that a precaster can help you with your panel layout. They can make sure that you're designing it the most efficiently. You can use the optimum use of punched openings, make sure those panels are large enough to be efficient, but not too large to ship down the road. They can help you with samples any precaster is going to be glad to make you some 12-inch by 12-inch color and texture samples. We'll hit on the sampling process in a moment. And then specification assistance. There are some things that are boilerplate about specifications, but there are also nuances about precast specs. Every project is different, and it's good to have a precaster review that written specification, someone that's familiar with the project, to assure that what's being presented in writing aligns with the graphic design drawings. And they can help you choose your certification project, whether that should be an AA project, an AB project, an AC project, or an AD project. And we'll define those designations here at the conclusion of the hour. Another great strategy for working on precast is with a schedule. And the model that you see here at the top is your traditional design, bid, build project. So you get through your 100% CDs, then you go out to bid, then you get your subs on board, then the precaster starts their shop drawing, their process, their engineering process, their sampling process, their production process, and then they get it out to the job site and they build it, and then they enclose it, which is a fine way to do things, but it takes quite a while to do that. So even though once the panels show up, they go up incredibly quick. So people that are really savvy about their precast procurement, what they've learned is to set it up where they are getting the precaster and often the steel producer released early. And that can be done through budgeting and negotiating with a preferred precaster, or I know on a lot of these schools, they're public bid and they do require getting multiple bids. So in that case, you can issue an early core and shell package just for the purpose of getting your precaster and your steel producer on board early. Then they become a design build partner. Essentially, they're helping with the details, they're helping to ensure you get as much out of the design you can, while also keeping the cost under control. And then that process is happening simultaneously, the shop drawing process and engineering process and production, with 100% CDs. So then all the other trades bid out at a later time, and you save a significant amount of time on your project, which with schools, they are time sensitive projects. They typically just have a certain window to build those projects, especially if it's an addition to an existing school. And there's obviously a lot of aesthetic flexibility with schools. The sampling process typically starts out with a PCI color and texture selection guide. There are a number of 3-ring binders that are out there, but this also exists online on PCI's website, and many specific vendors host this information on their website as well. It's a good jumping on point because you can give a PCI producer a plate number based on those hundreds of choices you have in there, and then they can start to make physical samples, which we encourage. The example at the bottom here, the precaster first did the sample on the left, then the architect said, we like it, but what would it look like if there were more dark aggregates? So they moved to the sample that you see there in the middle. And then they said, well, we like it, it's even better. Can we do a version where we punch up the dark aggregate a little bit more and go darker on the die? So that's when the sample to the right was issued, and they said it's perfect. They showed it to the owner, they got it approved, and they actually took a picture of that sample and they put it in with the specifications or with the addendum, and they even named the precaster as the basis of design. The important part of that is, if this sampling process hadn't happened ahead of the bid, you might have had a precaster that got on board and started with the sample on the left and said, well, we can do the one on the right, but it's going to be a change order, because there was actually, even though it wasn't a budget buster, there was definitely a cost difference between the one on the right and the one on the left, because there was more dye, there was more black rock in the mix. But it's good to have that understood ahead of time and everyone to know what they're walking into during the bidding process. It might seem like you're giving an advantage to one producer if you're working with them during the process, but it's interesting how this works. I'll give you a real world example. I was working on a school a number of years ago in Baser, Kansas. I was working with the architect. We were looking at the design, working through details, samples, the whole gamut. A counterpart of mine that works for my competitor, his name's Brian, great guy, good company. He was doing the same thing in Osawatomie. And he's working with the architect on the design, the details, the samples, everything. They were both schools. They both came out to a public bid. Interestingly enough, my company ended up getting the school that Brian was working on. Brian's company ended up getting the school that I was working on the front end. They matched our samples. We matched their samples. It worked out just fine. But anything can happen in that hard bid process. Once a precaster's on board, though, they will commence a full mock-up process, and that is going to typically be at least a 4 foot by 4 foot panel, but we often see sometimes more elaborate mock-ups that are designed. Sometimes they want to show a window or different materials in the panel. It's a great process because you can really see what those reveals are going to look like, the depth of them, the size of them. There's sometimes even opportunities to make little tweaks at the last minute as well. So that's a very positive process, and it's emulating the full casting process. So that's important to see in your mixed designs. With insulated sandwich panels, you have 2 widths of concrete that are surrounding insulation. As somebody put it to me recently, he said, a precast sandwich panel, that's like precast on a diet. And it really is, because you've got something very efficient. It's going to be, relatively light for a full building envelope system. You can put on the exterior either exposed precast with a finish, or in this case, you can see it's thin brick. It's going to be connected on the inside either by, there's a number of ways to connect it. It can be fiberglass pin connectors about every 24 inches on a grid system, or in this case, you're looking at a carbon fiber reinforcing grid that runs every 24 inches vertically, the entire height of the panel, giving it full composite action. Another a great benefit of precast, especially in schools that they know people are going to be in for a number of years, is the thermal mass effect. So you can see here the day-to-day cycles of temperature in a building when the heat when the heat is actually turned off or turned down during the evenings. And what you see there in the orange is a conventional building, and you actually see some pretty significant swings in temperature during those off-peak hours when the systems aren't running. With precast, on the other hand, what you're seeing there in blue, there's less of a temperature differential. The precast thermal mass flattens out daily temperature differentials and therefore reduces the heating and cooling loads of a building's HVAC system. And the way this occurs is you could almost think of it as a battery. That concrete is absorbing that heat during the day as a building is being heated. And when they shut down those systems in the evening, it actually begins to slowly release the heat into the interior spaces during the late afternoon or the evening when these buildings are empty. So when they show up an hour before the kids are going to show up and they boot up those systems again, it's less work for the HVAC system in the morning to rebalance that temperature. So it's energy savings that they'll see many times over the course of the project. There's a couple of ways to skin the cat with insulated sandwich panels. The top example you see here is what's called a non-composite panel. That is when you have a thick withe of interior gray concrete, and it is doing all the structural loading and lateral loading and so forth. And then you've got on the exterior a thin veneer, and that thin veneer is actually just serving as a moisture barrier and as your exterior facade. It's not doing anything structurally. And then of course it's connected by a connector system, and that is a fine way to do things. There's times on a high level FEMA high wind shelter where you want to do a non-composite panel for structural reasons. But all things being equal, another great tool you have, or another great way to do things, is what's called composite panels. And that is where you have more equally spaced withes of concrete that are connected in a way that they are actually sharing the loading on each side. So that's literally acting as one panel. So the advantage of composite is you can essentially, in some cases, do the same thing structurally, but it can be done with less concrete. So you're offsetting more expensive, heavier concrete with less expensive insulation. So you've got less, you might be able to get less loads, less crane size, and so forth. So in this case, in this example, they snuck in an extra inch of insulation, and it ended up being a higher R value. So they were 21 and change as opposed to 16 and change. And R value, obviously not to be confused with thermal mass. R value is the thermal resistance in a panel. You want your R value to be as high as possible. And thermal resistance can also be measured in a U factor, which is thermal transmittance. So you'd want your U factor to actually be as low as possible. And there's a few ways to go with load-bearing panels. And here's a few examples. You've got embeds that are going to be set into the precast. It can be either directly welded. There can be an L-shaped steel piece loaded that the joist can sit on top of, or there can be pockets. And your precaster or precast structural engineer or engineer of record can help you as an architect to make that best decision for your project. But one thing I will tell you, if you're working with composite panels, a good chance something you'll run into eventually is a situation where there is an embed or a slotted connection that needs to fit on the interior but doesn't have quite enough space. And in that case, you can actually notch into the insulation. It's okay to do it just in a small zone. You can even get it down to 1 inch, but the key is to not fully break that insulation. You want to continue the continuous insulation per the ASHRAE standards. You want to maintain that thermal break and not have any kind of thermal bridge between the panels. So that's just something to watch out for, during the shop drawing process. There's a few ways you can go on the corners. The left is a miter joint, which is a nice way to dress up an integral color panel. L-shaped pieces can be done. That's a little bit of an extra step. It would be a 2-day pour. They'd pour one on one side, one on the other side, or one the next day. They would turn it up, pour the other side the next day with a cold joint. We see that a lot on column covers where they want to have 2 pieces that go together instead of 4 pieces. And you can do the traditional butt joint. If you're doing a thin brick project, you'd want to do a butt joint as opposed to a mitered joint so that you can really sell that illusion of that thin brick being a full brick. We're not going to talk a lot about high wind structures. There's been some other hour-long seminars that have covered that quite thoroughly, quite comprehensively, but I did want to say what we typically see for precast, you will see a gymnasium area like you see in the blue here on the bottom of the screen, where they have, they'll take a high volume space, they'll put a double T roof in it, it'll have proximity to restrooms, and that will serve as your high wind structure. These tend to be very beefy, very heavy panels, but they work really well. An interesting trend that we're starting to see around Iowa and Nebraska is architects are figuring out if they actually take a lower volume space and make that their FEMA shelter, like you see in the yellow, either a multi-purpose room, a cluster of classrooms, maybe a library, something ideally with proximity to restrooms. They can do it with lower walls, and so they've got less premium wall space. It's something that's done for economy. It keeps the cost down. You know, in some cases, they'll use a steel roof instead of a double T roof. I can't get a lot into the specifics of cost because of some antitrust stuff, and there may be some debate the way cost trends are going now whether you're really getting any savings with a steel truss roof. But that is something to look at when you're really pinching pennies on projects. Another great tool, many precasters offer a thin version of an architectural insulated cladding panel. So this would be a what would traditionally be a 444 panel, 12 inches thick, weighing about 100 pounds. You can do with a 242 panel. This is 8 inches thick. So the R value doesn't change because the insulation is the same. This is something through research and development. The technology has gotten to a place where it allows us to do this. Now, this would be not in a load bearing, this would be a non-load bearing condition. But and the panel you see here, the example is 10 feet tall by 30 feet long, but that height of the panel could be adjusted based on the height of each floor of the space that you're designing it for, as long as it's not so tall that we can't get it down the road. But we've done 12-foot panels, we've even done 14-foot panels in some cases. So that is something that, you know, you're cutting your concrete in half, so your panels are going to weigh less. There's going to be less shipments to the job site, a little bit less of a crane that you'll need to install those, and they can even right size the footings and foundations, because at 50 pounds a square foot, that is actually less than it would weigh to do a conventional masonry system with a backing wall built behind it. So I could encourage you to talk to your local precasters about that option. And I'll circle back to the idea of taking these complex panels like this with curves, multiple mixed design or multiple finishes, board form patterns. The way to see some economy in doing that is through repetition, whether it be a high-end parking structure or with form liners, board forms, similarity of pieces. That's a way to control some cost. So I'm going to cap this hour here and with a quick discussion on PCI certification, and I want to leave some time to ask questions. So PCI is an organization that members get, in order to belong to, they get 2 unannounced audits per year. They basically don't know when the independent inspectors are showing up. They take the shop drawings out of the foreman's hands. They check the curing, the reinforcing strength, the quality. They talk about, or they get into safety, finish capabilities, and it's something that in order to belong to it, you just really have to maintain a high standard. So that's the benefits of PCI. They revamped their system about a year ago because of new technology advancement that allowed for even higher standards. So it was a way to align producers based on their capabilities. They got feedback from over 160 producers, architects, and contractors, work with precast a lot, had a lot of opinions, and that went into effect October of last year. So the previous categories were A1, which was a bit of a catch-all for architectural panels, CA, which was more industrial panels, warehouses, stadiums, double Ts, and AT, which is small projects, trim units. So what's happened is A1 and CA have been broken up into 4 categories, and that is what's called AA. That is the height. It has a heightened tolerance that didn't exist before, great emphasis on shapes and complexity. There's AB, which also has that great emphasis on shape and complexity. You can do curves, that sort of thing. The tolerance are actually consistent with the old A1 standards, 117. Then there is AC, which is your typical wall panel with architectural finish. It is probably the most similar to the previous A1 standard. And then AD, which is most similar to the CA structural standard. That is your more utilitarian panel. And then AT is still small projects. So where this, I think this will come together here for you a little bit. You can see here going left to right, AD, these projects are going to be your warehouses. They're going to be your more simplified big box stores. They do allow you to do an architectural finish and thin brick, but for all practical purposes, most of these AD projects are going to be structural gray projects that are going to be field painted. With AC, you've got more of your typical architectural panels. You can do a finish, you can do more than one finish on the same panel. So some of your, more simple schools are going to fall into that AC category. And depending on how much complexity you've got on your school facade, you might consider AB. AB is where you can start to do curves. You can start to embed other materials like stone and terracotta, so you can embed other things besides thin brick. There's more emphasis on projections and shapes, where AC panels tend to be a little more flat in nature. And then they have AA, which is kind of like that on steroids. It's a tighter tolerance that has not existed before. So these would be your campus performing arts centers. These would be your cathedrals. These would be the projects that are just going to be, they're going to be so particular and have so much scrutiny, they have to go just right. So producers are certifying for each of these categories. If they're an AA producer, they can bid a project with any of these categories. If they're an AC producer, they can't jump up and bid on the ABs and the AAs. So from a practical standpoint, if you're used to getting 5 bids on a precast project and you specify AA, you might just get 2 or 3 bids. But there are going to be producers that are qualified for that standard. Another important point that I want to make is every category that you see here represents a very high standard. This is a PCI certification level that has to be proven. So even though they're different, a different set of standards and criteria, each one of these represents a very high quality solution. And there's producers that say, hey, we know who we are, we're going to just stay in our lane, we're going to be an AC producer. And that's great, because there's a lot of AC projects and they're big volume important projects that need a lot of attention. But it distinguishes projects and producers based on that capability. Here you can kind of start to see, in order to go through that certification process, there's an AA sample of a mock-up in the top right corner, but for AD, you need to be able to do a flat panel with a reveal. With AC, that reveal needs to turn the corner and be able to stop abruptly. With AB, you need to be able to do more than one, not just more than one finish, but more than one mix design in the same panel. You need to be able to do curves, you need to be able to do projections. And with AA, you do that with more detail, with some additional tolerance. Same concept for thin brick. Very similar concept for form liners. And with AT projects, that category has largely remained unchanged, but there is an emphasis on samples to make sure that they can do that project with those projects with the precision that is required. So we're not going to get real into the weeds here, but there's a whole manual that covers this. But to give you a little bit more helicopter perspective regarding the tolerances, here you can see, if you read the top line, for panels that are over 20 feet long with AA, you can see you're dealing with tolerances of within a 1/16 of an inch. With AB, it's the old 117 standards, which is 1/4 of an inch. Same with AC, and then with AD, that loosens up to 1/2 an inch. So let's look at some project examples, and I'm going to go through them real quick because I want to save time for questions, for about 5 minutes of questions at the end. But for AT, small projects. You can see this little one-off medallion. This really shows you the level of detail you can get into on a 3D projection. And that was literally just the medallion in a masonry building. This project, Vincent DePaul, was done with a similar concept, but a different method. It was done with graphically imaged concrete. So it's printed on a membrane paper with a retarder, and then it's cast on top of that. The membrane paper is pulled off and it's washed, and wherever that printed retarder is, it exposes a very finite rock. So you have a combination of form finish and exposed aggregate. The art teacher of this private school actually designed this medallion, so you had an unprecedented amount of owner involvement. And this is perfect for if you run into municipalities where they require 1% of your project go towards permanent art. You can use that 1%, use a portion of it to hire an artist to do a custom design, and then also to facilitate the graphic concrete. For AC and AD categories, you've got single color panels. You can do thin brick, you can do form liners, single pour returns. For anything AC and above, a PCI certified erector is going to be required. So an AD project example, this warehouse, you can see some ways that they have dressed that up through painting different zones. And there was a wing wall there by the entrance that kind of broke up this large utilitarian project. So that gives you an idea of what an AD job might look like. With AC, you can see you can do a really nice school project with an AC. You can't do curves or multiple mix designs, but you can do multiple finishes. You can do thin brick. So utilizing some creativity can yield impressive results on an AC project. Here's another example of an AC, and one of Vanessa's schools she talked about earlier. And this is also an example of with thin brick, you're not just limited to just a continuous single running bond pattern. There's creative things you can do. When you step into the AA and AB categories, you're getting into multiple colors within a single panel. You can embed not just brick, but stone, tile, terracotta. You can do curved panels, those L-shaped pieces we talked about. You can do cold joint returns. AA steps into a tighter level of tolerance that has ever existed. These projects are going to have a project survey by an architect or a contractor, so that's a new level of accountability that didn't exist before. And AA projects are actually going to have a PCI site visit and audit for each project. So that is also an additional level of accountability. For AB, this business school at the University of Kansas, if there's any KU fans here, this is across the street from Allen Fieldhouse. You can see how the projections here and how they come out to an apex, a point, and it's interesting when the sun hits it, different times of the day. So you can see the emphasis on additional forms and tolerances. And each panel had a different theme, or there were some flat panels, there were some panels with things happening in different planes. There's some copper, so you got precast playing pretty well with other materials, some cantilevers, a big hall on the inside. That's the Capitol Federal Hall in Lawrence. You can also do curves with AB or AA panels. This was a gentle enough curve that they were actually able to set thin brick into it. The brick itself is not curved, but the panels are. And then there's Murfreesboro. This project was actually a performing arts center that was done in CMU with a wood truss roof. It collapsed. So fortunately, nobody was in it. Nobody got hurt, but there was a lot of political pressure to build with something really durable. They decided to do precast, and while they had all these eyes on it, they wanted to do something innovative from a design standpoint. And that was with this graphically imaged concrete forest pattern. This building hardly had any right angles in it. If you're doing graphically imaged concrete, we encourage you to use a precaster that is either AB or AA. This is another example of a graphically imaged concrete school that had a full 3D form liner at the bottom. So that's an example of those tools playing well with one another. And then when you get to AA, here you can see at the University of Nebraska, their College of Business, when you're making an investment in natural stone like a limestone, that's where you really might want to start to look into these tighter tolerances. You can see on the left there the different stones that are in different planes, but they're actually set into a flat panel. And that's a lot of work and coordination. But if you look to that repetition mode, that is used again and again and again and again. So there's great repetition on this project. That's an example of an AA project. Another AA job in Wichita, Kansas, this learning library. It has 3 different mix designs, 3 different finishes. So you have exposed aggregate, sandblast, acid etch. Up in the top left, you see a geometric pattern. In the bottom right, there's a curved undulating pattern. Here in this conference room in the top right, you can see how the precast came into the conference room, created a nice interior to exterior connection. And if you're saying, oh, wow, that's a lot of information, it is in terms of the certification. So I'm going to leave up on the last slide here a website that you can go to learn more information. In fact, I'll just go ahead and go to my final slide here and show you, if you're interested in reaching out to me personally, you can reach me at enterpriseprecast.com. I also encourage you to go to pci.org/PCI Midwest to explore the full range of PCI Midwest producers. You got some great producers doing impressive work. And if you go to pci.org/ArcCert, that's where you can learn more about the PCI certification system. And with all of that said, I hope I got through talking before you got through listening, and I've got a few minutes for questions, and I can hang around a little bit longer if there's more. I will also say any questions that I don't get to, I will make the commitment to email you a response. I will answer those questions. I just ask you bear with me. I'm going to be traveling a lot the next week and a half. So thank you.
Dirk, that was a wonderful job. Thanks for doing that. We appreciate it. Let's start answering some questions. We've got a bunch of them here. As a reminder, you can still submit your questions through the questions pane in the attendee panel. So, Dirk, our first question is 9 to 14 panels a day common during erecting?
It is, yeah. We probably most commonly see 10 to 12. But yeah, it's depending on the efficiency of it. When it's smaller pieces, you might see more in the 9. Complicated jobs, you might see more of the 9 range. If it's something really similar, like a warehouse, they'll do up to 14.
Okay. The next question is where you have an insulation within the panel, how do you force the interaction between the front and back portion of the concrete panel, which is separated by the insulation? I think what they're really talking about is connectors there, Dirk.
Okay, gotcha. So there's a number of systems or ways to connect a precast panel. So there are a series of fiberglass connectors that can be done on a grid, usually roughly about 24 inches, every 24 inches, but each panel is going to be engineered to the needs of that panel. There's also, you can do a carbon fiber grid that's going to run the entire height of the panel. And depending on what the goals of that panel is, whether it's a composite panel or a non-composite panel, that is going to define the density of those connectors and how those panels are connected and how they work.
All right. The next question is do the precast companies have input to what type of sealants are required to be used on panels?
So sealants, it's an interesting question, and generally speaking, we actually, speaking for Enterprise Precast, we actually recommend not sealing panels because with precast concrete, you've got less than a 6% absorption rate. So you have a face sealed product in and of itself, a natural product. Typically sealers are something that are done later by others, so I don't really it's kind of a non-issue to us whether it's done or not, but we have seen some issues with sealers where they'll go on unevenly or they'll wear unevenly over time and they need to be resealed, in 10 or 15 years, and you're essentially creating a maintenance issue for your owner. The times that we do recommend sealers are if it's in an area where there might be some concerns about graffiti or something like that. We do see some graffiti sealers, but it doesn't need to happen for moisture.
Okay, just FYI, we are at 11 o'clock, and in respect to our attendees, Dirk, if you want to stay around, I can ask a few more questions, but for of you, but anybody that needs to go certainly can go at this time, and as you said, you'll get back to them. So let me ask, how do you satisfy 3/4 inch concrete cover on the reinforcing in the 2-inch white on the 242 cladding, considering that you need to have crisscrossing bars at the corner of each window opening?
So the way that is done is actually through a finite pre-stressing process that occurs in those wipes of concrete. That's how it's done with the thin panels. One of the things it does, it does really limit what you can do in the way of reveals. Now, can you ask me, Mike, that the part at the end of that question again about the window openings?
Yeah, how do you account for them?
Typically you're going to have just around the perimeter of the window, there's going to be either a blocking or there's another product called Tiger Lock that is used, basically gives the window something to nail to and to adhere to. But with 8 inches, you've still got plenty there for the windows to adhere to, but it's going to adhere to that blocking or the mechanism that is between the wipes of concrete.
All right, the next one, I'll ask just a few more. The next one's pretty simple. Where can I get a color and texture guide?
Okay, well, they are located on PCI's website. They're also located, if you go to, on the website you see here, enterpriseprecast.com, and you go to a tab that says resources, you'll see one of the copies there, and you can either view it or you can download it. If you talk to a local precaster, they might also be able to get you a copy of the actual 3-ring binder, because it's a nice resource to have in your office just to be able to physically look at it. So there's a few ways to get a copy.
Okay, 2 more questions. The second to last one is, where would I find information on standard form liners?
There are, well, we're in the question and answer portion, so I'm going to go ahead and drop a few vendor names. There's a great company called AP Formliner. If you go to apformliner.com, they'll have some great choices. There's another company called Fitzgerald Formliner that we've used a lot with a great deal of success. If you Google precast form liners, you'll see a lot of options, and you'll see a number of standard choices, but then a lot of these companies are pretty good about doing customs as well if you want to get creative and get even a little more outside the box.
All right, and the last one, can HVAC systems be downsized with precast?
They can, and they typically are.
Okay, because you answered that so fast, I'm gonna ask one more. Are composite or non-composite panels thicker? Which one is thicker, composite or not?
Your non-composite panel is typically going to be thicker than a composite panel solution.
Okay. Well, thank you, Dirk, and thank everybody for attending today's webinar. Remember, you should receive an email with a link to your certificate of attendance within 10 business days. Thank you again for taking time and joining us today. Have a great rest of your day.